Hi everyone, I'm Daniele Traversaro from the University of Genova, and today I'll present our work to you. Sonic Pi for TBL teaching units in Introductory programming course. Daniele Traversaro, Giovanna Guerrini, and Giorgio Delzanno. Why innovative teaching in computer science? Each year we have a high number of freshmen, but these numbers are mainly motivated by the job opportunities offered by our degree. In contrast, we have a lot of students with low motivation and autonomy, and that are not used to working groups. In addition, there is another problem related to the balance between difficulties and gratification reward in learning to program. To face with all these problems, our university has intervened with an innovative teaching project. And our proposal belongs to the innovative teaching project. We designed 2 small exploratory teaching units in the context of the first semester introductory to programming course, also known as CS1. Our target were first-year undergraduate students in CS, so bachelor degree. Why Sonic Pi? Sonic Pi is not the traditional computer programming language. In fact, it's a code-based music creation performance tool where each musical concept is represented by a basic computer programming concept. The musical domain is something that everyone likes and known, and it makes computer programming concepts such as data structures, iterations, and so on natural and easy to understand. But you can also teach more advanced concepts such as concurrency. In particular, Sonic Pi is a computer programming language with a steep learning curve, with a very simple syntax, similar to the spoken English. Here, I just put as an example a screenshot of a Sonic Pi interface, and as you can see, there is a register window where you can see what your running program is doing and other outputs, for instance, the print function. So if you want to implement the Hello World program, you just have to write print Hello World without including the libraries or define classes and so on and so forth. So this language is very suitable for introductory programming course. And you can also hear what you are coding through music, and so you can get a tangible and concrete response. The main topic of our first teaching unit was concurrent computer programming, which was complementary to CS1. We did this module on November 2019 using Sonic Pi and TBL. In the next slide, I will explain TBL. The main goals were strengthen transversal skills, in particular teamwork, team member accountability, and strengthen motivation, curiosity, and self-esteem, by showing that there is much more than sequential imperative programming, but in order to understand this advanced concept, you have to understand, to have a basic foundation on imperative computer programming. While the second teaching unit main topic was scope rules, which was a learning objective of CS1. We used the same strategies, the same methodology in Sonic Pi. Here the goals were strengthen transversal skills and motivation, and deepening of scope rules in preparation for the CS1 written exam. So, team-based learning. Team-based learning is a collaborative learning and teaching strategy that enables students to follow a structured process. It's a particular case of a flipped classroom, and it scales very well on large classes. In particular, TBL consists of modules that can be taught in a 3-step cycle: preparation, in-class readiness assurance process, and application-focused exercise. In particular, it consists of 5 essential components, plus an optional final peer and self-evaluation. Here you can see the immediate feedback assessment technique, also known as IF-ATscratch-card, which we decided to use for the TRAT, Team Readiness Assurance Test. They are similar to scratch and win cards. So teams, they have to reach a consensus and scratch the box corresponding to the correct answer. So they allow us to obtain immediate feedback and a gamification of learning approach. Quiz are multiple choice questions with 4 options, only one correct and all the other false. For the first teaching unit, we decided to focus on CS concurrency and Sonic Pi data structure, in particular race conditions, synchronization between processes in Sonic Pi queue and sync, sleep, Sonic Pi threads, live loops, list, and so on. For the second teaching unit, we designed quizzes focused on the C++ and Sonic Pi scope rules. Here the idea was that switching from one language to another requires an additional abstraction effort to understand the scope notion, regardless of the rules of a specific language. In fact, Sonic Pi helps you to hear the difference between local and global variables. In particular, it works on 2 different levels of scope: variable scope and synth scope. Synth are a little bit, are quite tricky because are global but thread local. Then there is the team application phase, where the task must follow the 4S framework, which means that the problem must be significant, must be complex enough to engage all the members of a team, must be the same problem for all the teams with a specific choice in a simultaneous report. After the task, groups, teams have to prepare a poster where they can share their reasoning, and this phase triggers a lot of discussion among teams. Here you can see the 4S task of both activities. On the left, there is the first 4S task, and we are asking to implement a program to generate a DJ music. Obviously, we have to implement more than one musical instruments, and they have to be synchronized with each other. In particular, students have to use the QSync commands to synchronize the live loops in the different buffers. We also assign 2 other extra exercises, warm-up exercises, in order to get students familiar and used to the new syntax of Sonic Pi. In fact, despite Sonic Pi has a very simple syntax, it still requires minimal syntactical knowledge. On the right, we can see the second 4S task. Here, teams have to complete an incomplete Sonic Pi code in order to obtain an ordered sequence of notes. And to achieve these results, they have to understand the Sonic Pi scope rules. Okay, this is the 4S task implemented in Sonic Pi. As you can see, teams used concurrency commands like queue, in thread, sync, but also define function or loops, and so on and so forth. So, some feedback from our activities. From the first teaching unit, teams perform better than individual, and in particular, the average number of correct answers increases from 5 to 7.6, but if you consider also the second attempt, it increases to 9. And in general, the final mark of each team is quite positive. I want to stress the fact that we decided not to evaluate this activity in the context of CS1, but this activity only had a formative value for students. And the feedback from the second teaching unit are more or less the same, where teams perform better than individuals. So in general, we had a high participation, more than 131 students. Teams perform better than individuals, and peer and self-evaluation results were compatible. On the other hand, we encountered some time and space limitations, and we think that our reward system can be improved. So in conclusions, this approach seems applicable to undergraduate students and courses, and this educational format can be customized and adapted to different targets, by age groups, by topic, and so on. In future, we hope to do these two teaching units in order to obtain more data and perform a data analysis to find possible correlations between variables and to use them in order to build new courses or just part of them. We want to design new teaching units based on Sonic Pi and TBL. For instance, we are working on a new teaching unit based on circular array that are learning objective of CS1 using Sonic Pi ring chain data structure. Then we want to experiment other innovative strategies like think per share or problem-based learning and other programming languages with a steep learning curve, such as Python. Finally, this approach could also be useful for master degree courses and not just CS1. Thank you for your attention.